Today we're going to do lesson 3.3, function notation. Does anyone remember the definition of a function? We learned it last week in lesson 3.1. So if you can't remember, flip back to lesson 3.1 and find that definition. For every input, there is exactly one output. All right. Then in 3.2, last Thursday, you learned what a linear function was. Anybody remember what a linear function was? What's the graph of a linear function look like? Okay, but what's it look like on the coordinate plane? It's going to look like a what? A line. Remember the first four letters in the word linear spell line. So the question today is not, is this a function? The question today is not, is this a linear function? Today we know it's a function. What we're learning today is a new way to write the equation of a linear function, and it's called function notation. So you'll notice right away your essential question says, how can you use the function notation to represent a function? Take your highlighter and highlight this little piece right here. That is the key to today's lesson. That is how you know a problem is written in function notation. Now, let's learn how to read this because we're going to see it quite a bit this year, so you got to know how to read it. And I want you to notice between the F and the parenthesis, there is no symbol. So what operation does that usually indicate? A number in a parenthesis with nothing between them, a variable in a parenthesis. What operation? Multiplication, all right? And what two-letter word, so that we don't have to say F times X, what two-letter word could you see in a word problem and know it stands for multiplication? Okay, it would be in a word problem, it would be in a math sentence that you were trying to turn into an equation, and it's on the screen. What's the two-letter word that represents multiplication? Of. So you see how you read this? You read it F of X. And that's important because you don't want to read it F times X. It's F of X. Now here's another piece of information that's important. Any letter can actually replace the letter F. 95% of the time, we're going to use F of X. But I do want you to add this because occasionally you'll see G of X and H of X. They tend to also be pretty common. But really, any letter that they wanted to, they could replace F with, okay? But it's that parentheses with that X inside that really lets us know that it's function notation. Now here's the second most important thing I'm going to teach you today. F of X and Y are equal to each other. So I can take F of X, I can rewrite it as the letter Y, and I have not changed my problem at all. They are interchangeable, they mean the same thing. And I'm going to show you that as we work through these problems. Now, example number 1 says evaluate. And I know this is a word you've heard before. It's not a word we've used yet this year. But who can tell me what it means to evaluate something? Solve. So if you have forgotten that evaluate means to solve, I want you to add that to your notes. Half the battle in math is knowing what the directions are asking you to do. So if you don't understand that evaluate means to solve, you might struggle with what to do. But it says evaluate the function for the given values of X equals -4, 0, and 3. So we're going to do exactly what we did last week when we did the guacamole and the avocado problem. We're going to create a chart that has X, the function, and Y. Now, before we do that, though, I want to show you. We said F of X equals what variable? Y. So let's rewrite this first function with Y equals 2X minus 5 because I want you to see whether it says F of X or whether it says Y, it's the same problem still. So we're going to make this X and Y chart. We know our first column is our X, the middle column is our function, and the last column is our Y. Now, what are the X values that they want us to plug into this particular function? -4, 0, and 3. Now remember, when we plug numbers into equations, we plug them inside of what? Parentheses. We don't want to just do this because then it looks like 2 minus 4. If this is a positive number, we don't just want to do that because it looks like 24. So when we plug numbers into equations, we're going to plug them in parentheses because that's actually 2 times -4. All right, but Y equals 2 times 0 minus 5 and Y equals 2 times 3 minus 5. Now, there's 2 operations in this function. What are they? Multiplication and subtraction. Does it matter which one we do first? Yes. Which one do we have to do first? Multiplication. Please excuse my dear Aunt Sally. My dear, we got to multiply or divide. Then we, Aunt Sally, add or subtract. So 2 times negative 4 equals what? And negative 8 minus 5 equals negative 13. All right, 2 times 0. 0 minus 5. Beautiful. 2 times 3. 6 minus 5. 1. And we are going to box in the entire chart because I can see what you plugged in for x, where you plugged it into the function, and what came out when you worked it out. So box in the entire chart. And you've just evaluated the function for those 3 x values. Now look at letter B. We're going to do the same thing again, but this time I want you to leave it as g of x. Because remember, g of x and y are interchangeable. They're the same thing. They do not change the problem. So let's create our x and y chart. And we're going to keep the function g of x equals. Now you read this the opposite of negative x. I know a lot of times we like to say negative x minus 1, but it actually reads the opposite of x minus 1. And it's super important because when I plug in a negative number, there's already a negative in the function. It does not take the place of the negative in front of the number. And I'll show you what I mean here in just a second. But before I do that, what's my last column going to be labeled this time? Not just g. G of x. All right, we kept the g of x, so we're keeping it in the chart. Again, g of x is the same thing as what variable? Y. All right, now same 3 x values, negative 4, 0, and 3. So we have g of x. Now this is what I'm talking about. There's already a negative in the function. Keep it and then plug in negative 4. I see far too many people who drop the 4 off of the drop the negative off the 4 because they think, oh, there's already a negative in the function. No, those are 2 separate negative signs. So they both need to go into the function. Then we have g of x equals the opposite of 0 minus 1. And g of x equals the opposite of 3 minus 1. Now what do you notice right off the bat here in this first function? Double negatives. And double negatives have to be changed to what? Both positive. So now we have 4 minus 1, which is what? 3. Do we have a negative 0? Is there such a thing? So 0 minus 1 is negative 1. And the opposite of 3 is negative 3 minus 1, which is what? Negative 4. So again, keeping the g of x, keeping the function notation, did not change how we did the problem. Any questions so far? All right. Example number 2. It says find the value of x so that the function has the given value. Now again, I want you to pay really close attention. It says find the value of x. For whatever reason, these problems give my students issues on my quizzes and my tests. And this problem is actually meant to be pretty simple, but make sure you know what you're trying to find. Because if they're asking us to find the value of x and at the end your problem says f of x equals, have you found what they asked you to find? No. All right, but let me show you where the mistake comes. First of all, if you notice there's this tiny little semicolon right there. You have the function on the left side, f of x equals 6x plus 9. And on the right side, they tell you that f of x equals 21. Now here's the mistake that gets made constantly. My students take the 21 and they go plug it in place of x. But is that what they told us that x equals? No, they told us that f of x equaled 21. And what does f of x represent? What other variable? Y. So let's rewrite this. Y equals 6x plus 9. Bring down the semicolon. Y equals 21. So when you see it like that, where should the 21 be going? Where the y is, not where the x is. So we're going to plug it in, and 21 equals 6x plus 9. Now I told you guys from the beginning, algebra comes with us. We learned equations and solving them in chapter 1, and here we are in chapter 3, and we've got to solve this equation. So what do I do first to get x by itself? Subtract 9. Good. What's 21 minus 9? 12. And it equals, we bring down what we haven't used, which is 6x. Now how do I finish solving for x? Divide both sides by 6. We know that 6 over 6 is 1, so we just bring down x equals. Remember, we like the variable first. And what does x equal? 2. Have we found the value of x like it asked us to? Good. Again, if you were to end up with f of x equals, you should stop and think, I've done something wrong. Now let's look at letter B. Leave h of x this time. Leave h of x, but again, recognize where that little semicolon is because here's the function on your left, and this time they've given us the value of what unknown? H of x. So where's the -7 going in the function? In place of h of x. Again, not in place of x, in place of h of x. So -7 equals 2/3 x minus 5. What are we going to do first? Add 5 to both sides. So -7 plus 5? And it equals 2/3 x. Now what are we trying to move so that x is by itself? Now be careful. We're moving 2/3, but you got to pay attention to what they're doing with 2/3. Okay, are they adding or subtracting 2/3 to x? No, they're doing what with 2/3? Multiplying it. So how do we move it to the other side? Multiply by the reciprocal. Technically, yes, divide, but we can't divide fractions. So we learned a shortcut. We multiply both sides by the reciprocal. What is the reciprocal of 2/3? 3/2. And we know over here it equals or simplifies to a 1, which again, we do not need. So we're going to go ahead and write x equals, because we want our variable first. Now be careful over here on the left. -2, if I wrote it as a fraction, would be over what?
1.
So does anything simplify before we multiply? The 2's. What goes into 2 and -2? What goes into it? 2. 2 goes into itself once, and 2 goes into -2 how many times? Be careful. -1. Okay, the negative can't go away. -2 divided by a +2 is -1. So when you multiply 3 times -1, what do you get? Do we have a denominator anymore? Technically we do. What is it? Do we need it? No. Did we solve for x again? Yes. Now, example number 3 says graph the linear function, and here's what I need you to understand. These instructions right here and this original problem is all you're going to see on your quiz tomorrow and your test in a week or two. Here's why I'm telling you this. Because you see those 3 little steps that I've given you underneath the directions? They are not going to be given to you on the quiz tomorrow. They're not going to show up on the test. This is me giving you the steps to graphing a linear function. So we're going to highlight those 3 steps, and you are hopefully going to memorize them so that when you see these directions, graph the linear function, you're going to know exactly what to do. Now, first of all, let me ask you this. If we're graphing a linear function, what should our graph look like when we're finished? A line. Very good. So if for some reason your graph does not look like a straight line, you know you've done something wrong. So step number 1, which you are going to highlight, says to create an X and Y chart. You say, what's an X and Y chart? Exactly what we created back in example 1. So let's start. And first of all, let's start again. What can we replace f of x with? Y. Again, we're just showing that f of x and y are the same thing and it doesn't change the problem. So we've got our X and our Y chart. So we've got our X column, we have our function column, and we have our final column, which will be the Y. We're going to plug in X values, we're going to work out the problem, and Y value is going to come out. Now, do you see anywhere, again, remember, the directions are here, the original problem is here. Do you see anywhere in those 2 spots where you've been told what to do with X or what to use for X? Yes. Look at what I've highlighted. I have only highlighted graph the linear function and the original problem f of x equals 3x minus 2. Remember, that's all you're going to see tomorrow on the quiz. Have I told you in either spot what you're supposed to use for x? No. So what I have done though is in step number 2, I have told you what we're going to use for x. So again, you technically could be using any number you wanted, but this is what we're going to do to keep our lives consistent, to keep our ordered pairs small so that we're not trying to graph way off of a grid with really high numbers. And it also gives us one negative number, a 0, and a positive number. So you're going to have to remember that when you're making an x and y chart to graph a linear function, you're using -1, 0, and 1. Now we plug those in as we've been doing. So 3 times negative 1 minus 2, y equals 3 times 0 minus 2, and y equals 3 times 1 minus 2. Again, order matters, so we're doing what first? Multiplying or subtracting? Multiplying. What's 3 times negative 1? Negative 3 minus 2. Negative 5. What's 3 times 0? 0 minus 2? 3 times 1? Minus 2. 1. Now that's step number 2. We've used negative 1, 0, and 1 as x, also known as our domain. And the last step is to plot the points and draw a line. But here's my question. What points is it talking about? Carson. Okay, and where are we getting the x and the y? Because we need an x and a y coordinate for a point. Where are we getting those numbers?
The first x number and then the first y.
Good, right off that chart. We're gonna pull them off, and we're gonna put them over to the side. All right, so over to the side, Carson. What's the first ordered pair that you see?
Negative 1, negative 5.
Very good. Andrew, what's the second ordered pair you see?
0,
And the third ordered pair, David?
1, 1.
1 and 1. Now again, notice how I didn't go straight to graphing them. I'm going to pull them off to the side first. Now we're going to graph them. All right, let's go back to the basics. If I'm trying to graph an ordered pair, where do I start?
0.
In the center, the origin, 0, 0. And then how many moves am I going to make before I plot a point? How many coordinates are in an ordered pair? 2. So remember, I don't just go to the x coordinate, plot a point, and then the y coordinate and plot a point. That's way too many points. I'm going to make 2 moves before I plot the point. Now, Pearson, I want you to tell me how to graph negative 1, negative 5, but please don't say over. Over doesn't tell me if I'm going right or left. I need to know right or left, up or down. Okay? So how do I plot negative 1, negative 5?
Go to the left, 1.
Go left to negative 1, and then, which is right here, but I'm not plotting that point yet.
Down to negative.
And then down to negative 5. That is where I plot my point, right here. Now, we're going to be graphing a lot in this chapter. We're going to be graphing a lot the rest of the year. So let me get you used to something that I want to see on your homework, quizzes, and tests. I want you to label your points. You say, well, how do I label them? When I say label, I mean I want the ordered pair. When I am grading, I want to be able to quickly see what point you plotted. So label your points, always, always, always. Even if it's not going to tell you to, but get used to the fact that when you graph something for me, I want you to label the point that you plot. All right, Tommy, can you tell me how to graph 0, negative 2?
Anywhere left or right.
Good.
0, x, and you go down 2.
Very good. So my x coordinate is 0, so I don't move right or left. I stay in the middle, and then I go down to negative 2. Again, I plot the point, I label it. JD, how do I plot 1, 1?
You go to the right 1
Uh-huh.
and go up 1.
I go to the right 1 and I go up 1, and I label it 1, 1. Now, the last thing it tells me to do is to draw a line. Here's the next thing I'm going to be looking for every single time. The line number 1 needs to go through all 3 points and through far enough that you are able to put an arrow on each end. You would not believe how many students leave the arrow off and lose points. It's such a silly thing to lose points on, but if you don't put arrows, you're not really graphing a line, you're graphing a segment of a line. Okay, the arrows tell me that the graph goes off in both directions forever and ever. So yes, you must have the arrows. Now, does this look like a line?
Yes.
All right, so then we can move on. If for whatever reason you ended up with a graph that looked like a V or an S or a half a circle, you need to go back to your chart and rework it because something is wrong. This is a linear function, so the graph should be a line. Now, as with a lot of things, there's exceptions to the rules. And my rule is that we're going to use negative 1, 0, and 1 as our x every time we graph. However, let's go ahead and start setting up our chart. And I want you to notice, we're going to keep h of x this time, but I want you to notice the function. It's h of x equals negative 3/4 times x minus 1. So we're going to be multiplying our x value by what kind of a number? By a fraction. Now, could we still do negative 1, 0, and 1? Absolutely. If what I say in the next couple minutes just completely confuses you, just use negative 1, 0, and 1. But here's what's going to happen. You're going to end up with y values that are fractions. Is there anybody who just loves graphing fractions? That's what I thought. Okay, so let me teach you how to get rid of the fraction. So this is the exception to the -1, 0, 1 rule. All right, I want you to go back to the original problem and I want you to find and highlight the denominator. What's the denominator of the fraction? 4. And then to the side of the problem, I want you to write yourself this note. Use the denominator. Use the denominator as your positive and negative number. Now think about what that means. Instead of using -1 and +1, we're going to use our denominator as the positive and negative number, which means we're keeping which number every single time? The 0, right? We're keeping 0. We like zeros. So what is that going to make our 3x values for this particular problem? -4, 0, and 4. Because we're using the denominator of 4 as our positive number and our negative number. Now, what if our denominator was a 2? What numbers would we be keeping? -2, 0, 2. What if our denominator was a 9? What would we be using? -9, 0, and 9. All right, so is everybody following along with what we're doing? Because watch what happens. We have h of x equals -3/4 times -4 minus 1. H of x equals -3/4 times 0 minus 1. And h of x equals -3/4 times 4 minus 1. Now let's go back to this first problem right here. You've got a 4 in the denominator and a whole number of -4, which if we wrote it as a fraction would go over what? 1. So you've got a 4 in the denominator and a -4 in the what? Numerator. So what can we do with these two 4s? Cancel them. 4 goes into itself once. Be very careful though. 4 goes into -4 how many times? -1. So now you've got -3 times -1, which equals what? What kind of 3? A negative times a negative is a positive. So what's 3 minus 1? 2. 3 times 0. 0. That's why we keep 0. We love 0, right? Because 0 minus 1 is -1. And then -3/4 times 4. Again, you've got a 4 in the denominator and a 4 in the numerator. So what will these two 4s do? Cancel. 4 goes into itself once. 4 goes into itself once. So -3 times +1 is what? -3 minus 1, which is -4. All right, let's pull these ordered pairs off the chart. Maya, what do we have first? Yes, -4, 2. All right, JD, what's our second ordered pair? 0, -1. And Trey, what's our third ordered pair? 4 and -4. All right, that sign definitely matters. Andrew, how do I graph -4, 2? From the center, we're going to go left to -4. Then we're going to go up to +2. We're going to plot the point and we're going to label it. All right, Carson, what about 0, -1? How do I plot 0, -1?
You start at the origin.
Uh-huh.
Go to the left 1.
Be careful. My x-coordinate is 0. So am I going right, left, or nowhere?
Not going in.
I'm not going anywhere on the x-axis. So from the center, I'm going to go where? My y-coordinate is a -1. Down to -1. Now be careful because -1 isn't labeled or numbered, but we can still see that they're counting by ones. So then we label it 0, -1. All right, and 4, -4. Tyler, how do we plot 4, -4?
You go over to the right to the 4.
Okay, not over. Remember, over doesn't tell me. I need right or left.
Go to right.
To the right, go right to 4.
Then go down 4.
Down to -4. Very good. And then we're going to label it for -4. And what's the last thing we have to do to finish this problem? Draw your line through it. Make sure it goes through both ends so that you can put your arrows on each end. Is it a straight line? Then the chances are very good that we've done it correctly. Okay, obviously we know we've done it correctly, but if you're on a test, if you've got a line, you're in really good shape. Now, last but not least, this is kind of a word problem, but really this is trying to get you to understand function notation a little bit better to prepare you for some things we're going to do in the future. But look at what this says. It says let f of t. Now, they've taken the x out and they've replaced it with a t. That's okay. This is still function notation. But they say let f of t be the outside temperature in degrees Fahrenheit, and let t be the hours after 9 a.m. Okay? So I want us above the problem to write this. F of t equals. What are they telling us that f of t equals? Outside temperature. So we're going to write f of t equals outside temp. And what does t equal in this particular problem? So you think temp, but that's not what it says.
Hours.
Keep going. It's hours
After 9 a.m.
after 9 a.m. So not just hours, but it's the hours after 9 a.m. Now, go down to letter A and let's look at what they've given us. All right? This is key. They have taken out the t, because remember, according to their original problem, this was f of t. They have removed the variable t and they've replaced it with a 4. So here's the first thing you need to understand. If they remove a variable and replace it with a number, they're telling you what that variable equals. So I want you to draw a little arrow from the 4. They took out a t, replaced it with a 4. So guess what they're telling us? They're telling us that t equals 4. Now there's another number up there, and there's another piece to this problem. Remember, we wrote t equals the hours after 9 a.m., but we also wrote that f of t equals the outside temperature. So we also need to know what f of t equals. Do we know what f of t equals? What does it equal? 75. Remember, they replaced t with a 4, but that's still f of t on the left side. So f of t is equal to 75. Now we've got to interpret what they've told us. So if t is the hours after 9 a.m. and t is equal to 4, what time is it now? Start at 9 a.m. and count 4 hours down the road. What time is that? 1 a.m. or p.m.? 1 p.m. So at 1 p.m. it's, what's the outside temp? F of t. It's 75 degrees Fahrenheit. And that would be the interpretation of f of 4 equals 75. Now take that information and go do letter B. This time they took the t out and replaced it with a what? So what are they telling us? T equals 2. Do we know what f of t equals? This time it equals 70, because remember, they have f of 2, but it started as f of t. So f of t equals 70. So interpret this. 2 hours after 9 is at 11 a.m. It's 70 what? Degrees Fahrenheit. So this is just a small taste of what we're going to do later on down the road, but it's really important that you understand whatever number is in the parentheses, they've replaced the variable. They're telling you what the variable that was there to begin with, they're telling you what it actually equals. And then the other side of the problem is telling you what the function equals. So the parentheses are x, the other side is y. All right, and like I said, this will make so much more sense as we move forward, but this is a really good start. And that is lesson 3.3.